So my session is called Beyond Virtual Machines, Tapping into the AWS Universe from FileMaker. My name is Jesse Barnum. I'm the president of 360works. And a little bit about myself. I founded 360works in 1996. I'm the original developer for a lot of our products. I spend most of my time on MirrorSync and CloudMail. 360 Deploy has been taken over by Joe Martin, as has Zulu. And so I'm certified in all versions of FileMaker as of Friday. This is, I think, my 5th time speaking at DevCon. I received an FBA award for outstanding contribution to the FileMaker community, which was very cool. And so I've been using AWS for a while. I started in 2009. The first thing that we started using Amazon Web Services for in 2009 was to host all of our downloads for our products. And so we've grown tremendously since then. We now get thousands of downloads per month. Our S3 bill is about $2.60 per month. So I like Amazon. And it's incredibly cheap, it's incredibly powerful, it never goes down. I shouldn't say never, Prime Day was not their best time this year, but it's incredibly powerful and reliable. And we have since moved all of our critical business services to AWS. And I'm not just talking about servers, although we've moved all of our servers too. We are now running, like for instance, when you do our licensing, every time you run our plugins, it's checking in with our licensing server, which is using Amazon Elastic Load Balancing. We make heavy use of Amazon Lambda. We use Simple Queue Service in many of our products. So that's what I'm really going to be showing you guys today. If you came to this session because you saw the letters AWS and you assumed I'd be telling you how to sell, I'm jumping ahead a slide. I'll come back to that in a second. Let's talk about what we are going to cover. We are going to talk about how you can interact directly with the Amazon Web Service APIs using FileMaker natively with no plugins. This has been fairly challenging because Amazon has a very intricate, let's just say, system for authenticating its requests to the Amazon service. And we'll talk about why that is and why there's actually good reasons for doing that. But it's a high barrier to entry. So most people who use Amazon services actually just download one of Amazon's Python, Java, C# SDKs, or JavaScript. They download the SDK and then they call it from their application, and the SDK takes care of all the complex signing stuff. It's not as easy to do that in FileMaker because they don't have a FileMaker SDK. But the good news is it's still just, for the most part, REST APIs. They're just complicated REST APIs. Or the signing process is complicated. So I'm going to show you how to get around all that complexity and talk directly to those Amazon APIs. And I'll show you some examples of useful AWS APIs for FileMaker developers. And by the way, all of this stuff cannot be done with FileMaker prior to version 16. 16 gave us a whole bunch of new cryptography functions with the crypt digest, crypt auth code, hex encode, sort values, and all the JSON parsing. That's all mandatory in order to sign the requests the way that they're needed for the AWS APIs. I'm going to show you 5 or 6 Amazon APIs, but really, and I'm going to say this again at the end of the session, I don't want you to walk out of here going, oh, we learned how to do audit logging with Amazon. That's not really the point of this. The point of this is to say, we learned that there's hundreds of Amazon APIs, and now we know how we can interact with all of them. So I'm just this is like the sampler appetizer that you get at Chili's. It's not really the main course. It's just kind of like, hey, there's a bunch of cool stuff out there, and you can go do it yourself. What we're not going to cover, if you saw in my session AWS, and you just naturally assumed, oh, we're going to learn how to deploy FileMaker Cloud, or we're going to learn how to set up FileMaker Server to run efficiently on AWS. You should have been in my session 2 years ago, in 2016, where I did a session on that. So this is not about that. This is not about how to set up FileMaker Server on EC2 or anything like that. I think at this point, a lot of people know pretty well how to do that, so I'm trying to cover some stuff that is very new. So, how many AWS services are there? The answer is 131, at least by my informal count. looking through their products page. And it's a dizzying array of stuff for media encryption and artificial intelligence and image recognition and tons of database services. And like the whole EC2 thing that you use to spin up FileMaker server virtual machines, that's all part of the API as well. In fact, anything that you can do if you've poked around the AWS console, anything that you can do in the console, that console is just calling all of their underlying web services that you can call directly. So if you know how to go into AWS console and spin up a new FileMaker server, then by extension, you could do the exact same thing from a FileMaker solution. You could have a button in a FileMaker solution that would say, I want to spin up a new T2 medium, and I want it to have these firewall security rules, and I want to spin it up from this AMI that I've already pre-configured with all of my settings and everything like that. And I want to do 2 of them, and I want to have them load balanced, and I'm going to set up an elastic load balancer, and that can all just be one button that can do that entire operation through APIs. So everything that you can do in the AWS console, you can do from FileMaker. I'm going to talk about 6 of them: Kinesis, SQS, Transcribe, S3, Translate, and Athena. If you don't know what these are, you will by the time we're done. And again, I just want to point out, this is the sampler taste. This is kind of just like, wow, there's lots of stuff out there. You can go to aws.amazon.com/products to see like all of them broken out by category. So I'm going to start with one of the simplest and earliest Amazon services called Simple Queue Service. First I'm going to show how it works, then I'm going to talk about why you would want to use it, and then I'm going to talk about how you actually make that request. So I've set my FileMaker zoom up. Is this legible mostly to people kind of in the back? Or do I need to zoom in on what I'm doing? A little more? Is that better? Okay, I'll scroll up and down a little bit as I go. Simple Queue Service is really easy. Here's a message. I say queue message, and that just sent a message to Amazon. Success is 1. It took 300 milliseconds to send that message. 4 of it was FileMaker doing all the cryptography stuff that it needed to do in order to generate the request. Another 296 milliseconds was spent in the network round trip to the Amazon service. I'll point out that all of the services that I'm using today are going to the Virginia region. There is a Northern California region, and there's also a Portland region and an Ohio region, and then there's like 9 or 10 other regions around the world. But all of this is going from Dallas to Virginia.
Do you specifically target each region when you make the request?
Yes. When you make the request, if I have a layout here, AWS settings, and I've got a pull down. So these are all of the cities and regions. Actually, I haven't updated this list. I don't think Paris is on there, and I think there's been a couple others that have opened. But yeah, you come to here, and I should have, I'm glad you asked that. I should have pointed out to start with, you will need, obviously, an Amazon account to do any of this stuff. When you set up your Amazon account, you'll get an access key and a secret key. Put your access key and your secret key in here. You can use my access key and secret key until about 15 minutes after the demo, at which point I plan on turning them off. But it's very easy to go get your own Amazon access key and secret key and try all these things yourself. And pick whatever region is closest to you. So that's Simple Queue Service, and it queues messages. So let's talk about why you want to do this. Simple Queue Service is used extensively in our CloudMail product. And so CloudMail, for those that don't know, is a mass email broadcasting system. If you want to send out an email to 20,000 people, then it's very slow, and there are all sorts of problems with trying to push that through SMTP. So what we do instead is we use Simple Queue Service to queue up 20,000 messages on the Simple Queue Service, and then we have an Amazon EC2 instance that runs Linux, actually, that pops those things off of that queue on the other end and then sends them out using Amazon SES, which is a simple email sending service. So there's 3 different Amazon services used in CloudMail, and the Simple Queue Service is a critical aspect of it because Simple Queue Service can take messages at any rate. You can send hundreds of thousands of messages per second to Simple Queue Service and not worry about running out of disk space, running out of memory, or overloading the processing capabilities of what's receiving it on the other end. So it's a fantastic way for like these bulk emails to just queue them up much faster than they can actually be sent out. And then the Linux box that sends them out doesn't need to have enough RAM or disk space to hold all the messages. It just needs to hold one message because it reads them one at a time off of that queue and sends them out. If I was sending to 2 million instead of 20,000, I could have a cluster of 10 Linux instances on Amazon that are all pulling off of the same queue. So the queue is really designed, it could be used for many things, but a common use case is a work farm cluster pipe. So that you pop work onto the one end of the queue, and you pop jobs off of the other end of the queue, either for one or many processing machines to send those out. So that's what Simple Queue Service is for. Let's talk a little bit, let's get into the nitty-gritty about how that actually works and how I'm sending those. What I'll do here is these are all of my queues. You can see a bunch of them are for CloudMail, because we use CloudMail internally. And you can see here's this test queue, which is the one that I'm using here. You can see that from this URL where it ends in test. That's my account number, and that's the word test. So if I look at this test, and I say view and delete messages, and then I say start, there's the messages that I've been sending. Here's a message again, and I can queue these really fast. And they're just pulling up, they're just queuing up as I send them in Simple Queue Service, waiting for something to pop them off and do something with them. So it's a really good distributed messaging system that kind of guarantees delivery to one or more receiving things. So I want to show you, before I actually get into the script, I want to show you what a Simple Queue Service request is supposed to look like. So for all of the Amazon services, the way to find all this reference documentation is just Google for AWS SQS API reference. If you search for that, you're going to find it for SQS. If you search for S3, you're going to find it for S3, et cetera. But it's very easy to find this reference documentation. You might want to read, they all have developer guides as well. So, the developer guide is kind of just like a description of what the service is and how it works and everything like that. But then the reference information is like this. On the left hand, we've got the list of all the types of things we can do, such as creating a queue, deleting a batch of messages, listing queues, et cetera. So even though this seems like a very simple service, there's still, 24 or so operations that you can do. But the core one is this send message, and of course, receive message. So for send message, it delivers a message to the specific queue, and then these are all the kinds of parameters that can be sent. Most of these I'm going to skip past because the required here says no, not required. So these are all optional times. You can delay messages from showing up. You can have key value attributes that accompany a message. You have message body, which is required yes. So that's the most important thing. So what is the actual body of the text that you want to send? And by the way, you can do binary data too. You can base64 encode it and push it up to Simple Queue Service so that you're sending binary data or JSON data or anything else that you want to do. All the other parameters here are not required. So this deduplication ID is not required, group ID is not required, queue URL is required. So the two things that we need are the queue URL and the message body. And then down below, it talks about what gets returned in that response. And then the last thing it'll show us is an actual sample request. So the sample request looks like an HTTPS post or GET to a particular URL, and that URL is what I have here. And the action is going to be send message, and then message body is the only required parameter besides the queue URL, which is up here at the top. So let's ignore everything that comes below this, other than this version attribute needs to be specified on all the requests because that's essentially saying the version of the API that we want. So we're trying to construct a request that looks like this. And it's really easy to construct a request that looks like that in FileMaker. But what this example does not show is the authentication headers that need to get sent with it. And that's kind of the barrier. And that's what I'm going to show you guys. I've written a script, and the script was not trivial, but it's very easy to use. So let's run this with a script debugger and see what it's doing. So I'm going to queue this message again, and I'll zoom in here. So what we're going to do in order to call the script is we're going to build up this JSON variable. And the JSON variable has all of the parameters that the script will need in order to do all the stuff that we're doing. So the first thing, and actually, you know what, this will be easier now that I think about it, to show you in regular script maker instead of the debugger, because it'll be easier for me to to double click on lines and show you. So let's jump to my simplified simple queue service messaging thing and see what I'm passing in. So I'm calling JSON set element to create a new variable that has some key value pair specified. I need to always, every single request that we send to any Amazon service, not just simple queue service, will need these things. It's going to need an access key. It's going to need a secret key. It's going to need the region code that you want to talk to. That pull-down menu that you saw on the other screen selects the region code. In the case of Virginia, that's US-East-1. You can Google for Amazon regions to see the complete list of regions and their codes. Curl options, I don't pass any curl options, but that just gets passed to the curl functions in FileMaker. Like for instance, if I wanted a timeout of 15 seconds, I could put that in the curl options and that would get passed through so that the request would come back after 15 seconds. And then this I'll talk about a little bit more later, but you can specify whether you want SSL, HTTPS encryption or not by setting this to a 1 or a 0. And you might be saying, wait a second, I'm doing my secret key. That seems important. I should probably have encryption on. We'll talk about that when we get to getting the authentication process. Now we're going to talk about some things that are more specific to simple queue service. There's a service name parameter that is needed in all Amazon requests to say which service you're using, and in this case it's SQS. And these are all things that you can see in that example. If you were to flip back and forth between that example that we were just on and this script, you would see that all those example parameters line up with what I'm doing here. And then the URL, which is that queue URL that I showed you earlier. So now I've set some simple queue service specific things, and now we get to the most important part, which is the post data that we're going to send. And the post data corresponds to essentially everything that comes after the question mark there. And so what I know we need is the action, the message body, and the version. So I'm applying that right here. Here's the version, and I just copy and paste that string straight from the example. The action, which is send message, just like we see here in the example. And then message body, and I just URL encode whatever my message is, again, just like they have it in the example here. And I'm going to do JSON raw, because if I were providing JSON data as my message, I wouldn't want to escape all that data. And then we get to the perform script part. So this calls the subscript that I've written. You don't actually need to know that much about the subscript. I'm going to show you some things in it, but you don't really need to know that much about what happens in it. It's for curiosity's sake, let's go into it and take a look at it. But everything that is in here, if you know this much, then you're done. That's all you need to know in order to call simple queue service, is what I've showed you right here. So let's just delve into stuff that is optional. So I've written this fairly extensive script. I've tried to comment it a lot so that it's easy for you to understand it and easy to use it. And let's talk about what it's looking for. And everything that's in here are all parameters that you pass into that JSON variable that you give to that Amazon, or to this FileMaker script. So we start off with just some timing stuff. You remember I showed you the duration of the request. I need to record when I start it in order to know my duration. Now I'm just going to store the script parameter in a variable, and then I'm going to extract some individual values that I need. I need the host, which is in this case US East 1, because that's the region I'm going to. The region, which is US East 1 as well. The service name, which we already set to SQS. The access key, which we set. The secret key, which we set. And then these are all of the different things that you might set for various different services. So the only one that I think I use for the simple queue service is the post data one. So if you recall in my last script, I set is this legible? Should I make it bigger, or is it good? Okay. Bigger would be good? Okay. So these are all of the things that I could set. The only one that I actually did set in the case of simple queue service is this post data. And anything that we provide as post data will be sent with the post data of the request that we're going to make. But you can see I can also set a file parameter. File in this case doesn't mean file in the sense that we're used to thinking about it as a file on the hard drive. It's basically the entire portion of the URL that comes after the host name. When you have a URL, you divide it into the host name, the file parameter, and the fragment. So the file is whatever comes after the host name. Query params, if I was doing a get instead of a post, I would just supply those get values in the query param. The HTTPS, that can be set to true or false depending on whether I want encryption or not. If some Amazon services will require you to set certain request headers, if you need to do request headers, which you'll see in some of the later things that I do, you can just set those as key value pairs in the request header sub-element of the JSON. And then if you're doing binary data, if you're working with container data and you want to like upload or download container data, you'd put the name of the container field, not the value of the container, but the name of the actual field in this put container field. And then when we see that, we'll do an HTTP put and send that container data to S3, to whatever service you're using. I'm using S3. The method can be any valid HTTP verb, get, post, put, delete. It's rare that you need to set this method because most of the time we can figure it out by looking at, like if you set post data, we know you want to do a post. If you set query params, we know you want to do a get. And then curl options we talked about if you're doing generic things like timeouts, for instance. Everything after this, I'm going to leave to you if you want to scroll through and really get into it. But I will just give a quick overview of what's happening. So everything that's going to happen from this point forward is us generating all of the signature information that's needed for Amazon. And then we actually do an insert from URL, and then we take the result of that URL and we return that as JSON data in the script parameter, which you can then parse out to get everything you need from the response. And I don't want to spend a ton of time. It's all commented in here, but I'll just kind of very quickly skim through here. I think it'll make more sense when I jump back to slides because then you'll see examples of what it looks like at each step. The first thing we do is we generate a hash of the payload using the new crypt digest functions with the SHA-256 algorithm. We generate a canonical query, which is all the key value parameters. We URL encode them, we put them in lowercase, and we arrange them by case-sensitive sort order. Do the same thing with headers, make them lowercase, remove extra spaces, sort them the right way. And then we generate an overall string to sign, which is you'll see that in the slides. We hash that, and that generates a signature, which we use with our secret key that we passed in to generate a hash of a hash of a hash. And that's our final thing, and we then append that as a header to our request, and we run our curl thing with all of these headers that we've set. And I know I just totally blew by that, but it's not terribly interesting, and it's all here, and this is all downloadable. It's all in the session materials that you can get if you want to look at it line by line and see how it works. And here's where we actually run the request using our insert from URL command. And then after we get that, we just set a few different variables in our JSON result. So with that said, now I'm going to jump back to slides for a second and show you what that actually looks like with some actual data. So this is the same SQS thing that I just did. It's there's a link here that shows you on Amazon in detail what the steps are to sign the request, and that's everything I just skimmed through in that script. So if you have a burning desire to rewrite that script, you can look at this URL here and you can see the exact process that's done. And so that's all I did, was just follow that process step by step. And it's tedious, but it's not terribly difficult. So here's what the original request would normally look like with no authorization stuff set. It's a post. Here's the file part that I'm going to and my queue URL. Can't click on that. And then just regular old HTTP stuff, the host, the user agent, accept, content, length, content type, and then the post data that I provide in. So this is a very plain vanilla post. The only thing that's missing is all of the AWS signature stuff. So what we do is we generate a SHA-256 hash of our post data right here. And we put and by the way, if you want to just like put your head down and go to sleep or whatever like this, I'll wake you up when we get to the interesting parts, because this is really kind of just like stuff you don't have to know. I want you guys to know it because I don't like black magic myself personally. I just like knowing how stuff works. And if you like knowing how stuff works, then that's what I'm trying to show you. If you just want it to work, then just wait till I get to the cool demos. So totally up to you. If you gloss over all this, you're going to be fine for still doing everything that I want to show you. So we generate a SHA-256 hash of our post payload, and that's right here. And then we need to put a date and a time in every request, so we add that there. We then take, sorry, I went up instead of down. We then canonicalize the request, and canonicalizing it means putting it in a very consistent, repeatable format that is not random in terms of which headers come first and whether it's uppercase or lowercase. The reason this is important is because the way Amazon is going to eventually authenticate this request is they are going to also canonicalize the request, and they need to do it exactly and precisely to the individual byte, the exact same way that you do it. So it has to be case sensitive, it has to have the right number of spaces before and after colons, it has to be in alphabetical order, it has to exactly match the same way that they do it. So we canonicalize the request, we hash that whole thing together, and that's what this white text is a hash basically of all the stuff that I had in my canonical request. I'm jumping up and down. So this is my canonical request, we hash that, and that becomes this white text down here. The red text is stuff that we add telling it which service that we want to do, this SQS, which region we want, which is this US East 1, what version of the hashing algorithm we're using, which is the version 4, the current date, that kind of stuff, and the algorithm we're using to do the hashes, which is SHA-256. So now we've generated that string. We will then take this whole string and hash this to make this signature right here. And then this, and we hash that together with our secret key, which Amazon will also have a copy of our secret key. But notice an important thing, we are not going to send our secret key at all. Our secret key never gets sent to Amazon. Our secret key gets used to hash all of these things. And so Amazon is going to take our request and hash it with the same secret key we're using, and then at the end it should match. So we're not saying, hey, here's my secret key. We're saying, here's a bunch of hashes of hashes of hashes that I generated with my secret key. And if you generate the hashes of hashes of hashes with the same exact process using the same exact key, you should wind up with the same exact result. So that's what this final signature is. And then we put that signature back into our original request right here. Here's our hash of our payload. Here's our current date. And here's the hashes that we put together from the previous pages on the previous slides. So why? This seems awful. Why would anyone do this? There's some really compelling reasons to do all this. Number one, very interestingly, is that if the content that you're sending is not particularly sensitive, you could just turn off SSL and you can send everything over HTTPS, which is typically about 3 times faster. And there's no secret data being sent over. None of your access key is sent. Your access key actually appears in that request right here, AKIA such and such. But your secret key is never sent in the request because Amazon already has your secret key on file and they're just doing the same algorithm. So there's no confidential data being sent from Amazon's perspective. It's up to you to decide if your data is confidential that you're sending. Sometimes it is, sometimes it isn't. But if it's not, then you can skip the SSL encryption and get much faster throughput. So that's one nice thing. It's immune to replay attacks because all of the dates and times that you keep sticking in all those headers are only valid for 5 minutes. So if somebody were to intercept this request, even over a non-encrypted channel, and try to replay the attack later to pretend to be you, they would only be able to do that for 5 minutes before that becomes invalid. So it's immune to replay attacks. It never sends the secret key over the wire, as I've mentioned. It's immune to man-in-the-middle attacks so that they, again, if they do a DNS poisoning attack and they attempt to get you to route your request through them, there's nothing there that's of interest for them to get. They don't get your secret key, and they cannot just replay that thing later to do something. They also cannot modify the contents of the parameters that you're sending because the hashes of the hashes include the payload that you're sending. So if a single byte gets changed in the message that you're sending, those hashes are not going to match. it avoids an extra login HTTP request. So let's take FileMaker, for instance. Let's compare this process to the FileMaker data API. And I'm not knocking FileMaker because I don't think any of us really want to go through this to talk to the data API. But the FileMaker data API, first of all, you send your secret key, you send your password over the wire. Now, hopefully you're using SSL and hopefully that's secure. But it's better not to send it than to send it. So that's one big difference, is that in FileMaker data API, you send that over. Another big difference is that in the case of FileMaker, it's an extra HTTP request to send that thing. You have to send it first to get a token back before you can make a second request. So this does in one request what would ordinarily take two. Another big difference is that that token that you get back is valid for a certain period of time. I believe it's 15 minutes by default. FileMaker server needs to keep track of that expiration date and know when to expire it, and you need to know when that thing expires so that you can get a refreshed token. These are all issues that are solved by having this complex process. And the last point on this thing is probably actually the most important from Amazon's standpoint. Remember, there's not a single FileMaker server that you're talking to at the end and says, oh, hey, Richard, I know who you are. Here's your token. You're good for 15 minutes. There are like 10,000 machines at Amazon that are taking your requests. And if you send 500 requests, they could go to 500 different machines to process that. Imagine in your head what it would look like to have several million simultaneous users, all with their own individual expiration dates for their tokens, that had to be simultaneously broadcast out to all other 10,000 processing machines every time somebody said, here's my token, now, or here's my password, now give me a 15-minute token. It would grind everything to a halt. So this is a completely stateless processing model on the server side, which is a key aspect to why Amazon is able to scale up to unlimited things like this, is because they don't need to do any distributed processing to keep track of like a token with an expiration date. So now I'll jump into some demos. The SQS demo was just there for simplicity. Now I get into some stuff that's kind of cool. So we talked about simple queue service. Let's look at S3. So we just released a new version of FTP, and it includes S3 support, and it can upload and download stuff. And you can certainly go out and buy FTP, and you can do S3 uploads and downloads, or you can come to my session. You can learn how to do it without a plugin. So S3 is a simple storage service. It's what we use to host all of our downloads, as I mentioned earlier. It's intensely scalable. You cannot overload it, and you cannot run out of space. So I've got here, let me look at my S3 console. I didn't quite clean up my practice stuff, so let me clean that up right now. Okay. So I've got my test.360works.com bucket. I've got my DevCon 2018 subfolder, and then inside there I have an upload file subfolder. And at this point, I'm really not going to dive into scripts that much anymore at all. I'm really going to be talking more about what you can do. All these scripts are really going to be very similar to the SQS one that we looked at, so I'm not going to belabor the point by going over all of them. So if I click upload, did I click upload? I can't even tell. Oh, yeah, it went. So that took 1.3 seconds to upload that file. And if I look over at my S3 console and refresh it, there's the file I just uploaded. It was 701 kilobytes. If I want to download that, I'm just going to duplicate this record and delete the container data, and I'm going to click download. So that took half a second. And I don't know why that's not showing. All right, I'm going to keep going.
Is there a delay, or should it be instant?
It should be instant, and I'm seeing a valid result from Amazon with an HTTP 200 OK. So I'm not sure exactly what I did there. I'm seeing an error code 10 from the FileMaker insert from URL, which I think often means that a socket got closed unexpectedly. So I don't know if that's a little network glitch or what, but hopefully that won't continue for some of the examples that I want to show to you. What I'm going to talk about next is transcription. And transcription, this is one of the newer Amazon services. And I'm going to go ahead and just start it right now and then talk about it, because it's not real time. It takes about a minute or two to do what it's going to do. So I just clicked that button that said start transcribing. And good, this time I got an error code 0, so whatever was causing my issue there is not an issue anymore. That took just under a second to send that file out, and the file that I just sent was already on S3. So in order to use transcribe, you first upload some audio file to Amazon, which is what I just did, and then you give it a command to start transcribing. And so I've used like Siri for transcription, and it's kind of helpful, but this is, I think you'll agree, quite cool. So what I'm going to show you here is the audio file that I just uploaded.
When, in the course of human events, it becomes necessary for one people to dissolve the political bands which have connected them with another,
Created equal, that they are endowed by their
these ends, it is the right of the people.
Indeed will dictate mankind are more disposed to suffer, while evils are sufferable, than to right themselves by abolishing the forms to which they are accustomed.
So, a few things that you'll notice maybe about this audio. Number one, it's several different speakers. There was no training done for any of these speakers. Another thing you'll notice is that there's not a comma and a period spoken at the end of each thing. There's no punctuation being spoken. Another thing that you may notice is that the recording quality is quite good. This is actually NPR's annual reading of the Declaration of Independence. It's done by various NPR hosts. They're all professional announcers, so they speak and enunciate much more clearly than I do. And it's good recording audio. So it's, in some senses, a best case scenario. But if you compare it to a lot of transcription software that I've used in the past, it's kind of a worst case scenario in the sense that it's a bunch of untrained speakers who are all, it's a bunch of different speakers that the software has not been trained to understand, and they're not doing any punctuation cues. So with that in mind, let's jump back to our transcription demo and get result. It may not be done yet. Oh, come on. I wonder if something was wrong with the actual S3 file itself. It's 0 bytes. Okay, this is important enough to try and, what's that?
It's done in the sample file, it's all there.
In the sample?
That I downloaded.
Oh, okay. You tried it and it worked?
No, it just was already there.
Oh, okay. I'm going to upload this one more time. All right, that's there. Nobody else uploaded. Maybe that's what it was, is maybe somebody else was trying to upload at the same time as I was. Let's see if...
Your secret key, right?
Yeah, you do. You, of all people, should not have my secret key. That time the download worked. So I think that's probably what it was, is that it was a 0 byte file, so somehow I think somebody else may have been trying to upload at the same time. So this is going to take usually about 1:40 seconds, which is what I just covered. So while I'm waiting a minute or two for this to go, any questions so far on what I've been showing? Yeah?
So what's your gut take on, you said this is great quality, great speakers. I get my iPhone and I get a transcription from the voicemail.
Uh-huh.
It's pretty hideous.
Yeah.
Right?
Yeah.
So is this better than that? Or?
Yes, it is better than that. I use this myself. I've built a little personal iPhone app, so I like to run, and there's a trail across from my office. And I will go to that during lunch, and I'll either run or walk, and I just record every idea that I can think of while I'm out there. And it's really nice because there's like hawks and turtles and deer and stuff like that. And I just think of tons of ideas, and I've got a little FileMaker Go app that I wrote, and I just click a button and I say my idea, and then I hit stop. And then I use MirrorSync, of course, to sync all that back up to the office when I get back to the office. And then on the server side, it runs all the stuff through the Transcribe API, and it is not absolutely perfect, but it's quite good. And another feature that I forgot to mention, it's not in my normal presentation practice, is that there's also an optional ability to specify vocabulary. So if I have proper nouns or things like that, or the word MirrorSync, it doesn't know MirrorSync, which it should, but it doesn't. And so, that's one of the custom words that I've put into my vocabulary list. So instead of saying nurses sink, it'll say, it'll know MirrorSync and it'll put that in. So you can customize your vocabulary as you go too. And I find it to be not quite good enough to just send an email out to somebody without reviewing first, but absolutely good enough that I can read my own notes afterwards and know exactly what I was talking about. Yeah.
Obviously, languages beyond English.
It supports Spanish and English. And they're adding new languages. Yeah. Let's see if this is done yet. Okay, and this actually is interesting because I want to show you what the result looks like. So the transcription is not done yet, but what I want to show you here is, so I sent that request. It took 763 milliseconds to send the request to get the job. And what it says down here is one of my things is transcription status in progress. So this JSON data here is actually what I get back from the transcribe. And it's kind of interesting a little bit. Like I can see, okay, our language that we specified was English, which I just put up here. Here's the URL that we're transcribing. It read the sample hertz rate frequency, so we can see it's 44.1 kilohertz audio. There's a channel identification set to false. Another feature that I forgot to mention, which has to do with channel identification, and I'm not using it for this demo, which would be interesting, is that it will also identify different speakers and label them as speaker 1 said this, speaker 2 said this, speaker 1 replied with this, and speaker 2 replied with that. And to make that even more accurate, you can also do channel identification. So if you're in a call center environment, for instance, and you're recording, a lot of the times call center software will record the caller on the left audio and the call center operator as the right channel. So this is really good if you have call center audio and you want to run it through and see, you know, the caller said this, the operator said this, the caller said this, the operator said this. And I can see the job name and I can see the transcription job status. So even though this isn't working yet and it's not finished yet, it gives me a chance to kind of show you what the responses look like that you get back from the transcription service. That is the only way you can do it. I'm sure, at some point, almost all of their APIs that work this way have an ability to call simple notification service, which is yet another Amazon API, which can hook back to webhooks that you provide. So it's not there, because Transcribe is one of their newest services, but I'm sure that in the next 5 to 6 months, they'll add hooks into simple notification service so that it could make an HTTPS call back to FileMaker server, alerting server that the job is done and that it can go pick up that transcription. In my application that I use right now, I do an every 10 seconds until it's available. A polling loop, yeah.
So when we sent this out, did we send this with SQS to get it queued up?
No, I did S3 to upload the file. It could have been done with SQS. Like for instance, if I had a huge batch of jobs that I wanted to transcribe, I could put all of the URLs into a simple queue service, and then I could have a little VM or a Lambda service or whatever that pops each audio file off of a simple queue service and post it up to the transcribe service. Yeah, so you could do that in a high volume environment. So here's my result. Take a look at this. It's pretty good.
Speaker 1, speaker 2?
I did not have time in my demo to turn that feature on, but notice that it got the commas, and notice that it got the periods, and it didn't just do that by listening for pauses, it actually did that using artificial intelligence and grammar analysis. So it has a pretty good idea of, grammatically speaking, what should constitute the end of a sentence and where a comma would be appropriate, combining that with your pauses to determine that. So even though there was no punctuation, no spoken punctuation in the audio, it was able to do a very decent job of guessing at the punctuation. And I've actually done a diff of the text of the independence with this audio result, and the only thing that I found is that this word, suffering, should be like sufferable or suffered or something like that. I wish I could tell you exactly what it was. But this was almost just dead on word for word accurate. And what's also very cool is when you look over at this side here at the raw transcript result, look at this. Every single word. So the word people here has a transcription confidence of 1.0, and it was spoken at 6.521 seconds into the audio and ended at 6.801 seconds in the audio. Meaning that theoretically, if you wanted to, you could do something like highlight the transcribed thing and say, play this section of the audio so I can hear what this particular thing sounded like. Or you could click on a word and have it jump and start playing from that section of the audio, for instance.
So 1.0 is perfect? Or?
It's a new version. I mean, like I said, it's one of their newest services, and
No, I mean the confidence.
Oh yeah, 1.0 means it's pretty sure that it got the word right. Yeah, yeah. So let's do something, and this will only take a second. I'll show you another service here, which is Translate. So if we had had Amazon Web Services in 1776, and we wanted to send this to our French allies, we would have been all set. And this is very straightforward. This supports a lot more languages than transcribe, and it supports non-English languages both as the source and the target. And this is a very straightforward service to call, so that took about 2.5 seconds to translate that. Right to left? I don't know enough linguistics to really know how to do that, but I would assume that would work since Arabic is one of the languages that they mention up here, so I would assume that would work. Now, let's get into 15 minutes left, okay? So let's get into our interactive demo here. So remember this file right here, this personnel records Kinesis. I see somebody has been busy adding stuff. All right, Carlos? I can see you. So what I would like, let me think of the best order to do this in. If you've got this file open, try flipping through these records like this a few times. And then what I'll show you is that there's a script trigger here. And every time this script trigger runs, it runs the I set run on server to 1. I can do this with or without perform script on server. We put together a JSON string that contains all this audit logging information about who you are, your IP address. You didn't know that when you were doing this demo, did you? The platform you're on, whether it's SSL encrypted or not, all that kind of stuff is being gathered into a parameter and being sent to Amazon Kinesis. Amazon Kinesis is very much like Simple Queue Service, but it has more post-processing options of what you can do. So what I've done is I've configured Kinesis here's my Kinesis thing that I'm doing, FM audit log. And actually, I should have spent a tiny bit more time before I left out of that script. So if I had not been running it on the script, it would have gone to the Kinesis example 1, which if we look at it here, this is literally just copied and pasted from my other demo file because I had a Kinesis script in there that I didn't demo for you. And you can see there's a little bit more to it than the SQS because Kinesis has more options, it's a little more powerful. But this is literally just simply copied and pasted from that AWS functions thing. And the only change that I made is I made it so for its message, it uses whatever the script parameter is instead of a field that I had in my demo file. That's the only change that I made. And then it sends this using the same script that we've done with everything else to authenticate that request and send it up to Amazon. Now, something that I want to point out before I go further in this is the first time that I have used one of my AWS demos in an actual solution. So if this was your solution and you wanted to use some AWS stuff in your solution, all you would have had to have done, which is what I just did, is go to this AWS functions file that I ship here, that is included with our demo, copy the particular thing you want. So if you want to use Kinesis, or let's just say S3, you would copy this upload file example. You would also copy this send request parameter, and you would paste those two scripts into your solution. Once you paste those two scripts in your solution, you would customize this script to change which container field you're sending, and then you're ready to use it. It's really just that simple. I will point out one thing. If you are, the one exception, if you are downloading files and the target is going to be a container data, FileMaker apparently can't insert from URL. It cannot insert container data into a global variable. So that's the one time, instead of this script, you would use, which says returns raw response, you would use this script which says returns container data.
Is that a bug or a feature?
I think that's a bug. It feels like a bug to me.
Okay, so setting out of the URL.
Insert from container to a variable works for text data, but does not seem to work for container data. Yeah, and that's a FileMaker thing. But it's easily fixed. All you do is just, instead of insert from URL with result content as a target, you just insert from URL with a particular field that you want to insert into. So that's the only thing to be aware of there. So that's all I needed to do to incorporate that Kinesis stuff into this audit logging demo. So now let's talk about what happens with all this stuff that you're doing here. It is going to Kinesis, and then Kinesis is, I've configured a post-processing thing right here of Amazon S3 destination. And so what it's going to do is whatever comes first, whether it hits 1 megabyte of data or 60 seconds of time, it will gzip that data, and then it will put it in this S3 bucket. And if I look at my S3 bucket here, it's subdivided by date and time and hour and stuff like that. So all of these represent 1 minute increments of audit logs. And if I just pick one at random, I can see that that's the activity that occurred during that minute. I would show you, I'm getting a little short on time. I wanted to find one that had more records in it, but I want to keep going here. The point is that you wind up with a bunch of gzipped, compressed S3 data of every time anybody in here has looked at any record on FileMaker server. So you're like, well, that's cool. What would happen if I needed to find all the times that somebody had accessed a particular record? Would I need to download 10,000 gzip files and expand them all and hope that BBEdit would find all of those things or something like that? So that brings me to my last and final Amazon service thing I'm going to demo, which is Amazon Athena. Athena is able to do SQL queries against data stored in S3. And it will recursively, with a bunch of parallel processing threads, find every gzip file simultaneously, decompress them on the fly, and run an SQL query that you provide against that compressed data. It's super cool. It will also allow you to do joins, group by, halving, all that kind of stuff. So it's more than just simple filtering, and you could run, pretty intensive SQL queries against data that's stored in there. So if I want to say, find all of the people who looked at record number 12. So I'm going to run this query. It usually takes less than 2 seconds, 1.67 seconds. And I can see that these are all the people who have looked at record number 12 and the IP address that they were looking from, the device ID that they were on, the fact that they viewed the record, the layout name that it was viewed on, whether it was, what kind of network it was, whether it's Wi-Fi or LTE, whether it was secure, the timestamp that they looked at it, the UTC, Greenwich Mean Timestamp, all that stuff. I mean, that's just plain old get functions in FileMaker, right? But we just use those get functions to put together a JSON payload and then push that up to S3. And I'm going to talk a little faster because I'm down to 7 minutes. But so let's talk about the load that this generates.
Yeah.
If this was doing it with traditional FileMaker server methodologies, and you wanted to create a new FileMaker record every time somebody viewed one of the records in your solution, imagine what that would do to the performance of your FileMaker server. It would be awful. It would be completely overloaded with just trying to do audit logging, let alone it would have no time at all to actually use the solution to do the things that you were trying to do. So this is where I want to get you guys who are connected to my server to, whoever's connected to it, just flip through those records, and we'll do it for 30 seconds or a minute. And let's just see how much load we can put on FileMaker server. I'm going to do it too.
These are p-saucing out to...
Yep.
Okay.
Oh, nice, nice. Host capacity was exceeded. I set this to 500 beforehand, so there are limits here. Apparently, if we get enough people to hit it at the same time and just go mad on mashing the buttons, it is possible to do that. But what I want to point to you, even though the host capacity was exceeded, I'll bet you Yeah, the wait time here never exceeded 21, not milliseconds, 21 microseconds. And the reason for that is because when we're putting all this load on FileMaker server, it's not actually having to talk to the database. There's no commits, there's no selects, there's no index locking, there's no anything like that, because I got to hold questions for the end because I'm out of time. Because what's happening is that the JSON data is being pre-computed on the client, sent to the server, and the server is just simply passing that verbatim along to S3 and never having to look at any FileMaker records in order to do that. So all we're really using PSOS for is just the fact that you can check the boxes, don't wait for record results, and that way you don't notice any delay as you flip through those records. So think about this for HIPAA, think about this for GDPR, think about this for anything where you need to be able to view record activity or anything like that. And this could be used for just any, I mean, I'm showing it for FileMaker record logging because I'm a FileMaker developer, that's the first thing I think of. But think of what you could do with just the ability to store a massive amount of event data at any scale imaginable and generate no load, essentially, on your solution because Amazon is doing all that processing on their end. So since I've got 5 minutes left, I'm just going to jump back to a couple slides that are left. So a little bit of a homework assignment. So I want to stress again that I don't want you guys to leave this session going, oh, we learned cool audit logging stuff. I mean, that's fine. We learned cool audit logging stuff. We learned how to upload and download to S3. We learned that the Declaration of Independence is still relevant. What I really want you to go out of here thinking about is there is a boatload of cool stuff that you can do on Amazon. And now that we've got this little script that takes care of all that complex signing stuff, we can just start going to town on all of it. So a few services that are on this slide. I've used all of these services with the exception of recognition. In kind of my career. And recognition is something that I'm actually planning on doing. We're working on a thing with the ballet school so that as the dancers come in the door, a camera will scan their face and we'll take attendance by knowing when they're there as they come in the door. So, I mean, there's cool stuff that you can do. Lambda is, I think, going to be a total game changer. So read about Lambda and learn more about what it does, but that's all left as homework. There's no updates. Thank you guys very much. Please do the evaluations. It really helps me a lot, and I hope you guys have enjoyed it.